minus sign over here, right? And initially, this is our positive shear, positive bending moment assumption. So when it's negative, the right value, or sorry, the right direction is going down this way. So this is compression. Up here is tensile. Okay, as you can see. Now I'm going to show you another way of solving it. Okay, and this is looking is to look at what is happening, okay, at the built-in region. Okay, why I'm using different way of solving it, because I want you all to have the confidence, okay, to solve it either way, and the answer will be always be the same. Okay, so let's see how is this approach different. So I'm going to again, okay, so we're going to do this, and I'm going to call this our what did we call the point A? I think we used A already. I'm going to call this space, this entire location, our B location, our point B. Okay, so over there is our point B. So I'm going to do the different thing we're going to do now is we are going to look at the reaction at point B. Okay, the reaction at point B, and the answer will be the same. It has to be the same. Okay, so now if we were to look at the XY plane, right? I'm just going to sketch this out. Okay. And this is our element H, our element K. Okay. And I will draw our transformation based on the right hand X, Y, and this is rotation about Z. And we just need to look at our 150 pounds. Okay, the rest we can't analyze them because remember I told you guys ignore the dots and crosses. So this is your 200, this is your 150, and this is your 50, right? So we are going to assume positive shear now. So this is our point B, right? So this is our positive shear assumption, right? And then we know this is our BX direction. Okay. So from here, if we do static analysis, dimension of forces in the X direction is equal to 0. So you have 150 minus by BX is equal to 0. BX is equal to 150, right? And because it's in that direction pulling away, so you know that these are going to generate tensile stress. Okay. And then now if we will take moment about point B, right? So if we're going to have summation of moment in the y direction is equal to 0. So you are going to have minus moment. I better call this moment Z at point B. Sorry, this is Z axis, it's not Y. I do apologize. Right. So moment about Z at point B is negative, right? The 150 multiplied by the perpendicular distance is also going to be negative, minus by 150 multiplied by a distance of 8 is equal to 0. So moment Z at point B, right? So we know that moment Z at point B is equal to what? 150. Is it 8 or 10? Sorry, multiplied by 10. Okay. So it's equal to 150 minus 1500 inch. Okay. So minus means what? This direction is wrong. You just cancel it. And the correct one is this direction. So this is compression. And this is what? Tensile. Okay. So if now we use, okay, now we are going to use the analysis from left to right. Right. So now if we just look at here, right, we know that this is our what? This is our 1500. Right. And then we assume, right, positive shear over the other side. So this is our moment at A, right? Because we call this point B, we call this point A already, right? So why this is the case? Because this is why we assume this, because now we are doing our analysis from what? Left to right. Okay. So from here, Omar, are you okay? It makes sense, right? For this direction.
Yes. Yeah, it makes
Yes,
sense. Thanks.
okay.
Thank
So
you.
now when we have this, right, we do anything that's anticlockwise summation, moment, and I believe these are all in the z direction is equal to 0. Now we have minus, or both are minus. So now is minus 1500, right? Minus mz. I'll call this mz at point A. So mz at point A is equal to what? Is equal to minus 1500. When it's minus 1500 pound inch, right? It means that 1500 pound inch has to be in the opposite direction. So this is the wrong direction. This is the right. So this is compression. And this is what? Tensile. If we were to look into our previous method, right? Our previous method, right? The below is what? In compression, the top is in tension. Exactly the same. Compression is in tension. You need to have that level of confidence when dealing, and this is only by practice. Okay, I have that confidence too. I'm my notes. I did not intend to show this, but I know the physics work. Okay, the rules work. The level of you have to have that level of what? Confidence. Okay, then you'll be fine with this. Are we clear? So these are using static analysis. Okay, but personally, if you ask me which one I prefer method number one. Why I prefer method number one? Because I know this is 150, right? I know that this force will generate a direction going this way. I could visualize it. Okay, this is more of visualization. And also for this case, right? For the one down here where you have two forces, you can also visualize it. Okay, you can visualize it. Hey, these two load when they're pushing, they're only pushing at what? 1100, but the one coming down is 2000, and then you are very sure that the moment in z is going to be so moment in y is going to be in that direction. Okay, so you can use the visualization method, or if you want to use static analysis, okay, whether you take from the left hand side or from the right hand side, the answer will always be the same. Are we clear? And as I say, the level of confidence is important. Okay. Now let's do one more time. Okay, and we want to look at the reaction at point B. Okay, so now I'm going to look at the reaction at point B. Okay. And we are going to focus on the exact plane now. Okay, we are going to focus on the exact plane. So I'm going to sketch this out. Okay. So we know that we have a load down here at what? 150. We have a load coming down. This is at 200. We have a load down here going out 50. We have a load down here going at 150, right? And then this is our element, right? So one is our element H, one is our element K, right? And then positive shear assumption, positive bending moment assumption. So this is, so if I were to draw our, this is X, this is Z, right hand rule, rotation about Y. Okay, so this is our positive assumption, right? So this is our my M Y at point B. So this is my point B. Okay, this entire face is my point B. Okay, so I'm going to write down some dimension. We know here to here is 4, here to here is 4, and here to here is 6. Am I right? 4, 4, 6. I'm right. Okay, so we are going to take summation about moment in the y direction is equal to 0. Okay, we're going to take moment at point B, right? Or summation, yeah. So we will have minus, right? Because it's going clockwise, my at point B, right? Then plus by 150 multiplied by 8, right? Because we are taking from point B, right? Then plus by 50 multiplied by 14, right? Then minus 200 multiplied by 14. The whole thing will be equal to 0. Okay. So minus my at point B plus by 150 multiplied by 8, 1200, plus by 50 times 14, 50 times 14, 700, minus 200 times 14, 2800. So the numbers are different, yeah? So you have my at point B will be equal to 1200 plus 700 minus 2800. So minus 900. Okay. So 900 are we in newtons or pound inch? Right. So the minus means the assumption is wrong. This is the valid direction. Okay. So this is your valid